In 1997, underwater microphones in the Pacific Ocean picked up a sound. Not just any sound, a sound so powerful, so impossibly loud that it was detected across 3,000 miles of ocean. Here's what you need to understand. The oceans cover 71% of our planet, and we've only explored about 5% of them. So when scientists heard this sound, they had no idea what made it. The sound had a name, the bloop. And for years, people believed it came from something alive, something massive, something that shouldn't exist. But here's the twist. The truth behind the bloop is somehow even stranger than the monster theory. And what scientists discovered changed everything we thought we knew about our planet's frozen edges. Stay with me, because in the next few minutes, you're going to hear about Cold War spy equipment, underwater volcanoes, and what actually the loudest sound ever recorded in the ocean was about. Let me take you back to the summer of 1997. The Cold War was over. However, the US Navy had left something behind, something that would accidentally solve one of the ocean's biggest mysteries. The Navy had built SOSUS, the Sound Surveillance System, miles and miles of underwater microphones designed to track Soviet submarines. When the Soviet threat disappeared, NOAA, the National Oceanic and Atmospheric Administration, inherited this massive listening network, and they repurposed it. They started using it to monitor underwater volcanoes, earthquakes, and marine life. So why does this matter? Because without this network of spy equipment, we would have never heard the bloop at all. The system worked like this. Hydrophones, basically underwater microphones, were placed over 2,000 miles apart across the Pacific. These weren't your everyday microphones. They could pick up sounds from thousands of miles away through the ocean. Think about that for a second. The ocean is an incredible sound channel. Sound travels about 4 times faster in water than air, which means a loud enough noise can race across entire ocean basins. But in the summer of 1997, these microphones picked up something they'd never heard before. Never. Multiple sensors, separated by over 3,000 miles, all detected the same sound within seconds of each other. The researchers listening knew immediately this was big. This was powerful. This was unprecedented. So, what did the bloop actually sound like? The original recording was ultra-low frequency, too low for human ears. Scientists had to speed it up 16 times just to make it audible. When you hear it, it sounds like this. A rapid rise in frequency, almost like a whale call, but deeper, louder, more powerful. The sound blooped. It rose in pitch over about 1 minute, therefore the name. But here's what made scientists' hearts race. The audio profile looked familiar, too familiar. Christopher Fox from NOAA's Pacific Marine Environmental Laboratory analyzed the sound wave patterns. What he saw reminded him of something: marine animals. Specifically, the pattern looked similar to whale calls, a rapid variation in frequency. Whales change pitch when they communicate. They warble and shift tones. The bloop did the same thing. However, there was a massive problem with the animal theory. Can you guess what it was? The volume. The sheer, impossible volume. Let me put this in perspective. The blue whale is the largest animal ever known to exist on Earth, bigger than any dinosaur. When a blue whale calls, that sound can travel hundreds of miles. So, how loud would an animal need to be to produce a sound detectable across 3,000 miles of ocean? Fox himself said it. The creature would have to be far more powerful than the calls made by any animal on Earth, far louder than any whale,
louder than anything we'd ever documented. This meant one of two things. Either there was an unknown creature in the ocean larger than a blue whale, or something else entirely was making the sound. Think about what that means. We're talking about a potential creature that would dwarf the largest animal we've ever known, which means it would need to be, what, 200 feet long? 300 feet? Bigger?
The speculation started almost immediately. News outlets picked up the story. The internet was just becoming mainstream in the late 90s, and forums erupted with theories. What do you think people theorized? Giant squids, sea monsters, megalodon sharks that never went extinct. Some even suggested Cthulhu, the fictional monster from H.P. Lovecraft stories, might be real. But here's what made the mystery so compelling. Scientists couldn't rule any of it out. Not definitively. Not yet. Why not? Because of one simple, uncomfortable fact. We know almost nothing about the deep ocean. Think about this. We've mapped more of Mars than our own ocean floor. We've sent more people to space than to the deepest parts of our oceans. About 95% of the ocean remains unexplored. The deepest parts, the Mariana Trench, the Philippine Trench, they're over 6 miles deep. That's deeper than Mount Everest is tall. And we've barely scratched the surface of what lives down there. So, could a massive unknown creature be hiding in the deep? Scientifically, it's not impossible. We discover new species all the time. The giant squid, the creature of sailors' nightmares, wasn't filmed alive until 2004. That's over a century after scientists confirmed it existed. The colossal squid, even larger, wasn't captured until 2007. However, there's a difference between a large squid and something that could produce the bloop. What would the biological requirements be? Any animal that loud would need massive specialized organs to produce sound. Sperm whales have the loudest animal call we know. Their clicks can reach 230 decibels underwater. The bloop was detected across 3,000 miles, which means it would need to be exponentially louder. We're talking about an animal that would need organs the size of small buildings just to create that much acoustic power. And here's the question that haunted researchers. Could such a creature even survive? Large animals need food, lots of it. A blue whale eats about 4 tons of krill per day. Something larger would need even more. But the deep ocean is essentially a desert. There's very little food down there. Therefore, if a giant creature existed, it would probably need to hunt near the surface, where food is abundant. And if it did that, we would have seen it by now.
So if it wasn't a creature, what else could create a sound that powerful? The researchers at NOAA started eliminating possibilities one by one. First up, human activity. Could it be a submarine, a secret military test, some kind of underwater bomb? Christopher Fox went on record saying he didn't believe the source was man-made. Why? Because submarines are designed to be quiet, and underwater explosions have a very distinct acoustic signature: sharp, sudden, brutal. The bloop was gradual, rising over a full minute. What about underwater volcanoes? This was actually NOAA's primary mission, monitoring volcanic activity. The Pacific Ocean sits on the Ring of Fire, a massive chain of volcanoes and earthquake zones circling the Pacific. When underwater volcanoes erupt, they create sound, lots of it. The ocean floor is constantly rumbling with volcanic activity. But here's the problem: volcanic sounds don't match the bloop's pattern. Volcanoes create low, continuous rumbles. They don't bloop. They don't rise in frequency over time. Therefore, scientists crossed volcanoes off the list. Ship engines? Wrong frequency. Fishing boats? Too quiet. Earthquakes? Different signature. So, what was left? And why did it take scientists 8 more years to find the answer? The answer was location. Location was everything. Researchers triangulated the bloop's origin point using the different arrival times at various sensors. The math pointed to a specific area in the South Pacific, roughly 50 degrees south, 100 degrees west. That's west of the southern tip of South America, remote, isolated, and incredibly close to one place in particular. Where do you think? Antarctica, the frozen continent at the bottom of the world. In 2005, NOAA researchers continued their work. They deployed more hydrophones, moving them closer and closer to Antarctica. Their goal? Monitor volcanic activity and earthquakes near the South Pole. But what they discovered changed everything about the bloop. They started detecting sounds, lots of sounds, with spectrograms nearly identical to the bloop. Same frequency pattern, same rising tone, same acoustic signature. And here's the crucial part. They could actually see what was making these sounds. They were tracking an iceberg, specifically iceberg A53A, a massive chunk of ice that had broken off from Antarctica. As this iceberg drifted near South Georgia Island in early 2008, it began to break apart. And every time a section cracked off, it created a sound they called an icequake. Wait, ice can cause earthquakes? Not earthquakes in the traditional sense, icequakes. When massive icebergs crack, fracture, and break apart, they release enormous amounts of energy. That energy travels through the ice and into the water as sound waves. Think of it like this. Imagine snapping a twig. Now imagine that twig is the size of a city block, made of solid ice and breaking underwater, which means all that acoustic energy has nowhere to go but through the ocean. But why are these sounds so loud? It comes down to how ice breaks. When an iceberg fractures, it's not a clean snap. The ice is under tremendous pressure from its own weight. Cracks propagate through the ice, racing along at incredible speeds, releasing energy as they go. Scientists identified several specific processes that create these sounds. Let me break them down for you. First, there's something called calving. What do you think that means? Calving is when a large section of ice breaks off an iceberg. It's like watching a building collapse, except the building is made of ice, and falling into the ocean creates a massive acoustic event. The sound is short, broad spectrum, meaning it covers a wide range of frequencies, from 1 Hz all the way up to 440 Hz. It's created by the ice cracking and the crack propagating through the structure. Then there's rubbing. This happens when 2 or more ice flows, compacted areas of glacial ice, are forced together. They grind against each other, creating shear deformation at the edges. This triggers something called horizontally polarized shear waves. Imagine 2 massive ice sheets the size of cities grinding past each other. The friction, the pressure, the movement, all of it creates sound. And finally, ridging. However, what makes this different? Ridging occurs when ice bends or slides at pressure points called ridges. When the ice fails, when it can't handle the pressure anymore, it creates a crushing process that seals air gaps between ice flows. The acoustical signals from this are similar to a collapsing air bubble in water. And remember, these aren't small air bubbles. These are massive air pockets being crushed by thousands of tons of ice. So, all of these processes can create sounds detectable across thousands of miles?
Absolutely. The scientists found that icequakes could be detected on multiple sensors at ranges exceeding 5,000 kilometers. That's over 3,000 miles, exactly like the Bloop. When they compared the spectrograms, the visual representations of sound waves, the match was undeniable. The Bloop had the same acoustic signature as ice breaking apart. But wait, if they solved this in 2005, why didn't everyone hear about it immediately? The scientific process takes time. Researchers needed to confirm their findings, analyze more data, and publish their results. It wasn't until 2012 that NOAA officially updated their description of the Bloop. By then, the mystery had taken on a life of its own. The idea of a massive sea creature had captured public imagination. Therefore, when the real answer came out, some people were disappointed.
So the Bloop was just ice. Does that make it less interesting? Actually, the truth makes it more important. Here's why. The Bloop was an early warning sign, a signal that our planet's frozen regions were changing faster than we realized. What do you mean? Antarctica holds about 90% of the world's ice. When that ice cracks and breaks apart, when icebergs carve off glaciers, it's a direct result of changing conditions in the Southern Ocean. And here's what's happening. With global warming, more and more icequakes are occurring every year. Glaciers are breaking apart, icebergs are becoming more common, the ice is fracturing at an accelerating rate. Which means the Bloop wasn't just a one-time event. Exactly. NOAA's hydrophones have detected hundreds, maybe thousands of similar sounds since 1997. Each one represents another piece of Antarctic ice breaking away. Scientists use these sounds now as acoustic trackers. Therefore, when they hear an icequake, they can triangulate its position and track icebergs as they drift and disintegrate across the Southern Ocean. Think about what that means for a second. A sound that was once a complete mystery is now a tool for monitoring climate change. The researchers tracked iceberg A53A for months using nothing but sound. They could tell when it collided with other icebergs, when it scraped along the sea floor, when pieces broke off. One specific type of sound they detected was called harmonic tremor, when an iceberg contacts the sea floor or another iceberg and vibrates at specific frequencies, which means the ice is literally humming as it grinds along the bottom of the ocean. But here's the unsettling part. If these sounds are becoming more common, what does that tell us? It tells us the ice is disappearing. Every icequake represents ice that's no longer attached to Antarctica, ice that will eventually melt into the ocean. The more frequently we hear these sounds, the faster the ice is breaking apart. And as ocean temperatures rise, the rate of ice fracturing increases exponentially. Even though we solved the Bloop, the ocean still holds mysteries, doesn't it? Absolutely. Remember, 95% of the ocean is unexplored. We've identified about 250,000 marine species, but scientists estimate there could be over 2 million species we haven't discovered yet. The deep ocean remains one of the last true frontiers on Earth. So could there still be giant creatures down there? Could there be? Maybe. Probably not as large as the Bloop theory suggested, but the ocean is full of surprises. And here's what keeps marine biologists up at night. The deepest parts of the ocean are under so much pressure that most of our equipment can't even go there. The Mariana Trench reaches depths of nearly 36,000 feet. The pressure down there is over 1,000 times atmospheric pressure at sea level. Your body would be crushed instantly. However, life exists down there. We've found fish, shrimp, and microorganisms thriving in conditions that should be impossible. Which means what exactly? It means that life finds a way. Even in the darkest, coldest, most pressurized environments, something is alive down there. Something is surviving. The bloop taught us an important lesson. The ocean will always surprise us. We thought we heard a monster. We found breaking ice. Therefore, the next mysterious sound we detect could lead to an even more unexpected discovery.
So here's where we are. The bloop was real. The sound was real. The mystery was real. But the answer wasn't a monster. It was something equally powerful. The sound of our planet changing. The sound of ice that had been frozen for thousands of years suddenly breaking apart and sliding into the ocean. And the question we're left with is this: what will the next bloop sound like? Because Noah's hydrophones are still out there, still listening, still recording every rumble, every crack, every mysterious sound that echoes through the deep. Maybe the next sound will be another icequake. Maybe it'll be an undersea volcano. Or maybe, just maybe, it'll be something we can't explain. Something that actually is a creature we've never seen before. The ocean is listening. The question is, are you? The bloop mystery is solved, but the ocean's secrets, they've only just begun to surface.